Here's a problem on understanding the central limit theorem and how it can be used to find probabilities of sampling distributions. And I want to just show this problem first and compare a sampling distribution to a regular distribution. And they say here, rolling a fair 8-sided die. And again, that 8 there has nothing to do with really the problem in a sense. We're not going to use that to compute anything. So, and again, it's a uniform distribution, which doesn't really matter what the type is. We get numbers from 1 to 8. So you may be more familiar with 6-sided die, where you roll a die, it has the numbers 1 through 6. And again, that really isn't going to help us in doing these computations. What we want to keep in mind here is that the mean of this distribution is 4.5, standard deviation 2.291. So that is what I would refer to as a regular distribution, just a uniform distribution, meaning that the values from 1 to 8 all are equally likely to occur on any given single trial. Now, they say assume that n 8-sided dice are rolled many times, and the mean of the n outcomes is computed each time. So in other words, you could roll them one at a time. Say you'd want to roll the die 10 times and find out what the mean number is. So it might come up a 2, might come up a 7, might come up a 3, might come up an 8 each time you roll that. And so you average it out, and the average is 4.5. Standard deviation, again, 2.291. Okay, so again, that n 8-sided die just means that they rolled it 10 times, or they rolled it 12 times, or they rolled it 15 times, or so on. So we come down here, it says find the mean and standard deviation of the resulting distribution of sample means. So in other words, this mean here, 4.5, is of that regular distribution. Now if we create a sampling distribution where we would plot the mean every time we rolled that thing so many times, it would actually be the same. So you take, here's the mean 4.5. The sampling distribution mean is also 4.5. I'm going to type that in here, 4.5, and check answer, and good job. So we got that right. Now it says the standard deviation of the distribution of sample means is the original distribution 2.291, and the sampling distribution standard deviation is going to be smaller. Okay, it's always going to be that size or smaller, because you're going to take this number and divide by the square root of n. So I'm going to take 2.291 and divide by the square root of 81. Of course, the square root of 81 is 9. So I'm going to take 2.291 divided by 9. So 2.291 divided by 9 is 2.25455, and so on and so on. So it says round to the nearest thousands. So that's 3 decimal places. I'm going to put in 0.254, but I'm going to round that, so I'm going to make it 55. Check answer. Excellent. Okay, so we got that. And then we're going to repeat the process here. Find the mean and standard deviation if we had a sample size of 144. Well, the mean, original distribution, was 4.5. This one is going to be also 4.5. Check answer, good. Now, the standard deviation, we're going to take that original standard deviation, 2.291, and divided by the square root of 144 is 12, so we divide by 12, 0.191, 0.191, enter, great job.